On a hill in Vernal, 5,280 feet above sea level. I don't know how realistic these figures are for Vernal. If they're off and you're picky about that stuff, I apologize in advance. A 45-year-old archaeologist digs for bones and finds some 54 feet below sea level. That's a lot of digging, over a mile. It was 82 degrees Fahrenheit outside. How many feet must the archaeologist drill to find the bones? What information is important to solving this problem? So let's identify this second part. What information is important for this problem? So I'm just going to circle, because they gave us more numbers than we needed, of course, just like you would expect from math nerds making math problems, right? Well, what we're trying to find is how many feet the archaeologist must drill. So we don't care how old the archaeologist is. In fact, I guess I'll kind of use elimination here as well. Also, we do not care what the temperature was, so we don't care about the 82 degrees. That right there, just by the process of elimination, if you needed it, gives us, well, I guess I should, the 5,280 feet above sea level. And then the second part, the 54 feet below sea level. That's where the bones are. So those are the two values that we need on that one. I guess I didn't really circle them, but I underlined them. Okay, so we need to figure out how far the archaeologist must drill. So again, this one we're going to say, forget. So well, this is a difference problem, and I guess I could kind of draw a picture, whether you want me to or not. So this is 0 feet, and this is where the archaeologist is, and he's just a horizontal line, and then the bones are down here. So this would be 54 feet and below sea level. Since it's below, I'll put a negative sign on that, and the archaeologist is 5,280 feet above sea level. What we want to know is how far the archaeologist will drill, right? So he's going to have to go from the 5,280 to get to sea level. He's already got to go down 5,280 feet. But then the archaeologist also must go down another 54 feet. Now, hopefully this helps us to see what operation we're using. It's a distance between two values on what I've made as a vertical number line. So that right there tells me that I'm going to be using subtraction. Okay, since it's subtraction, I want the ending to be where to be my first value, which was the negative 54 degrees, and then my second value to be where we started to, I guess, dig. 5,280 feet. So this is a direct subtraction problem. It's not minus negative. The 5,280 is positive. It was above sea level. This is just the expression part. Of course, we still want the actual answer. And so we got a negative minus a positive. If you use keep, change to make this a plus an addition problem, which you could do, like I'm making it more complicated than it needs to be, just to see that you're adding two values that have the same sign. The reason why I'm doing this is because when we combine these two, we know the answer will be a bigger negative, which means we're going to take the big number, 5,280, and add the smaller number, 54. And that will be the distance between the two as a negative. So 0 plus 4 is 4, 5 plus 8 is 13 rather. 1 plus 2, there in the hundreds place value is another 3, and then the 5. So we end up at negative 5,334 feet. Now, this is a distance, right? I should put feet there, huh? How many feet must the archaeologist drill to find the bones? I feel like there's some redundancy there, right? The drilling and the negative. Because drilling would, in my mind, I think drilling for bones, you'd have to go downward. Yeah. And I mean, it seems weird. If you wrote negative 5,334 feet, to me, I'm okay with that. Again, the negative part here just has to tell us that it was to go down. And so if you just wrote down 5,334 feet, that's fine.